Now let's discuss reconnaissance scanning or penetration testing using NMap or Network Mapper. NMap is a utility which allows you to perform reconnaissance scanning or penetration testing against hosts within your environment or on the internet. Generally, you should use NMap for hosts or to scan systems that you have governance over, not to explore the internet or to wreak havoc on systems you don't own or nor are responsible for. So with that said, let's just label this section NMap for Network Mapper. And among its features includes the fact that it's a port scanner. It detects hosts and devices. It can also detect services that are attached to various ports on your network or on the internet, so service detection. As an example, if you're running an SSH or Telnet or FTP server, NMap will be able to determine that you're running those services and may even be able to tell you the version of the application that's sitting behind the port that it has found open. In addition, NMap supports operating system fingerprinting, which is the ability for NMap, using a database that it comes with, to determine the operating system based on the database of the system that it is connected to or detected on the network. So on our network we have multiple Linux and Windows systems as well as a Cisco router. NMap should have no trouble discovering the OSs of those systems using its operating system fingerprinting database. So there's a database of signatures returned by various systems that assists NMap or abets NMap in its ability to discern the operating system. Additionally, NMap can be used to target multiple hosts. In other words, it supports multi-target scanning, the ability to scan multiple hosts. For example, ranges of hosts, whether sequentially or out of order. So here are a list of features. Again, it's a port scanner, port/reconnaissance scanner. It detects hosts and devices, services, the ability to detect the operating system of the target host, and it supports multiple target scanning by indicating the multiple targets on the command line or via an input file. This is the tool that you should use to determine or set benchmarks based on your current setup, your current environment, and compare against those benchmarks on occasion. So for example, after you've set up an environment or have secured an environment, you should use NMap to create a benchmark, which will be a report generated by NMap which discloses ports, services, and operating systems and devices that are detected on your network. And then from time to time you should run NMap either automatically or manually to determine if there's been any changes to the configuration of your network. So a sixth feature would be, or is that NMap supports or produces reports. So it produces various reports of its activities in various formats, among other features, of course. Well, we need to install NMap, so let's set up our tasks here. We'll download the latest version. From the website nmap.org or insecure.org/nmap. Let's open our browser. We'll extract the URL for the download from the website momentarily. We'll navigate to nmap.org, and once the lookup is performed or completed, we will then have a connection to the remote server. NMap is distributed as an RPM as well as via source files so that you can compile the latest version on your system if you have compiler tools installed. So here's the home page. If we navigate to the download link, it takes us to nmap.org/download. And if we scroll down beyond the Windows binaries, as it is available for binary, it is multi-platform capable. It runs on Mac, Windows, as well as NIX-based systems such as Unix, Linux. We'll see towards the bottom the RPMs. Now, since Red Hat Enterprise Linux is RPM compliant, we should have no trouble installing the RPM. The latest version of the RPM is 4.5.3, and we'll right-button copy link location and use wget to download it, or optionally download it using the browser. Let's make sure we have a temp directory, and we'll wget then paste the URL, which will download the RPM to the server momentarily. And this is on the remote system. In fact, we can do it locally. It doesn't need to be on the remote system. So we'll download it locally to our local directory, make a directory temp if it doesn't already exist, and then wget the same link. It can be installed on either system. Both are running Red Hat Enterprise 5. This will be down momentarily, and once it is down, we'll use RPM UVH to install it. So after wget and the URL, we then execute RPM UVH, followed by the name of the package, NMap 4.5.3. i386 is the platform RPM. If you're running a different platform, by all means search for a different RPM, or download the sources and compile it, or download the source RPM, which is platform agnostic, then compile it into a binary form for your platform, such as 64-bit or Spark or some other platform, and you'll be able to then install it. x86 64 binaries are available in the dist directory, so you can download those as well from the distribution directory if you follow the link. We'll just stop it. We don't need to follow it because our operating system is 32-bit. So the RPM has been downloaded. Let's proceed. Now we can't install as a non-root user, so let's SU in. However, if we had the sources, tar-gz, tar-bz2 sources, we'd be able to install, even if only to the user Linux CBT's home directory and below, we'd be able to compile and install the package. But since we want this utility to be accessible to all users of the system, we need to be logged in as root and be prepared to install it as root. We'll RPM UVH NMap using tab completion, and this will prepare the RPM package to have it installed on our system. Shortly thereafter, we'll execute RPM queryless NMap to see the contents of the package and briefly discuss some of the important items. The main binary or executable is located in user bin, and it's known as NMap. So this is the primary binary, and it is accessible to all users of the system. If you run NMap as a non-privileged user, let's just note, executing NMap as non-privileged user causes it to operate in TCP connect mode instead of the stealthy TCP SYN mode. So keep that in mind. The difference between TCP Connect and TCP SYN modes is that in TCP Connect, a full three-way handshake using TCP is performed, which allows the target to know about the connection, usually traceable via the logs of the service that you've connected to. Whereas in TCP SYN mode, a halfway connection or a half-open connection is performed when NMap is executed against a target host, making it more stealthy. Many intrusion detection systems will be able to pick up on NMap TCP SYN scans, but by and large, most systems administrators of target systems will not see the half-open connections unless, of course, you open many of them, which creates many SYN or half-open connections in the connection table, and they'll be able to see those SYN connections by using netstat from the shell. So, for example, netstat ANT will reveal all TCP connections, and you'll see many half-open connections or SIM-based connections, which usually means that someone is port scanning you. But if you've got an intrusion detection package in place like Snort will be able to pick up on the scans. So this is the primary binary. The primary top-level directory for additional items is user lib exec nmap. Below we see documentation. Beneath user share nmap, we see files that nmap relies upon. So let's just copy this path. It's an important path. This is a top-level container for key nmap files, including but not limited to the OS fingerprinting database. And that's the nmap-os-db file. And this is the OS fingerprinting DB. Another important file is the MAC prefixes file. This allows nmap to map MAC address prefixes to given corporations such as 3Com, Cisco, Intel, etc. So it maps MAC prefixes to companies. And these are text files, by the way, so you can take a look at them using less. And you'll see that MAC prefixes are included for the major manufacturers. Xerox, Cisco, you name it. Fujitsu, 3Com, Novell. Pretty much all of the world's major networking suppliers are listed in this MAC prefixes database. And the databases that are available beneath user share nmap are updated with each release of nmap, if applicable, if necessary, which is why you want to keep this reconnaissance tool as up-to-date as possible. There are protocols that are used, and this is another resolution file, another database file. Let's take a brief look at it. In protocols, you'll find names of protocols and their numbers. So for example, IP is numbered 4, TCP is numbered 6, so on and so forth. NMap makes use of the protocols or nmap-protocols file to resolve protocol numbers that you'll find in TCP or in IP or UDP or in any of these types of packet headers to names. So this is yet another database which provides lookup so that it's translatable to us and intelligible to us, rather than us having to remember that 6 is for TCP and 8 is for EGP, for Exterior Gateway Protocol, and others. So there's resolution for the protocol numbers because indeed within the packet headers of the various packet types, UDP, TCP, IP, etc., the number is present, not the name. So resolution must take place, but of course this is all based on RFCs, so it's defined, the information is widely available. It isn't simply made up by the folks at insecure.org. A translation table for remote procedure call protocols. Service probes, services. NMap services is another important file. This file, as you'll see momentarily, maintains a list of key services that you'll also find in ETC services. It translates for TCP and UDP the common key services found on internetworked devices. These are older TCP/IP small services, echo, discard, but nonetheless they're listed. We see FTP data, FTP at 20 and 21, SSH at 22, Telnet at 23. You'll see the web at 80, SMTP at 25. All of the commonly used applications are listed in this particular document, nmap-services. There is an existing version for the operating system as a whole in ETC, known as services, that most utilities make use of, but nmap ships with its own. So it resolves service names to port numbers. Because again, pretend you're nmap, or pretend you're a low-level scanning or parsing tool or interrogation tool. When you sniff or intercept or generate or target systems, you're basically dealing with numbers. IP addresses for version 4 and 6 are represented in numbers, and the contents of various packets, whether it be GRE, IPsec, TCP, UDP, IP, you name it, the representation of those protocols are in numbers, not in names. So there has to be a way to resolve those numbers to names that are intelligible or make sense to us, the administrator/user. There are other files, other help files, other scripts that are included. Just check the documentation of NMap to get a sense for how useful these are and how they may impact your environment. Let's RPM query this again. This runs right through to the end of the scripts, and NMap comes with, like all other programs, documentation. It's a man page, man one page. So man NMap will tell you how you may execute NMap, what options are available, a description of how the software works, general usage, NMap with scan options, any additional options, and the target specification, which may be one or more hosts. So that leads us to the usage of NMap. Let's set up a section, and we'll spend the remainder of our time discussing usage. So simple usage. We want to scan, let's say, our local host. So scan the local host for open ports. That would be executed as follows. NMap-V for verbose. Verbose is a good idea to execute as it renders more information than less, or than what you'd typically see if you don't use V or lowercase v. Localhost. This causes a scan to the loopback adapter 127.0.0.1. Again, if you execute NMap as a non-root user, it will do so in TCP connect mode by default. We'll reset our buffer, which NMap, it's in user bin, it's in our path, and then we'll execute it. We've executed it. If you scroll towards the top, NMap always tells you that it's starting a particular version with a reference to insecure.org, the suppliers and developers of NMap. In addition, you'll see the date and time that the scan was executed. The time is represented relative to UTC. This is UTC time. The type of scan is followed immediately on the second line. If you're logged in as root, the type of scan defaults to a SYN scan, which is a half-open stealth scan that is detectable by most intrusion detection systems like Snort. The time is always preserved. The target host, its IP address, and the number of ports that were scanned. Here are the ports that NMap found to be open: SMTP, DNS, SSH, Telnet, many others, including CIFS, X11, RPC services, Samba SWAT, VNC, and NetBIOS services. All the services that we've set up throughout our studies of Red Hat Enterprise 5. Towards the end of the discovery, if any ports have been discovered or not, you'll see the fact that NMap has completed the type of scan, whether TCP Connect, SYN, or any of the other types of scans supported. It tells you when it was completed. Some scans take a few seconds, others may take a fraction of a second, yet others may take minutes and hours, depending on the depth of the scan, the connectivity between the client and the server, so on and so forth. In this case, it took a fraction of a second, 24/100ths of a second, and as a result, it came back pretty quickly. It started at 17:57 and ended at 17:57 UTC time. 1,714 total ports were scanned within 24/100ths of a second. The host appears to be up. NMap uses a combination of tactics to determine whether or not a host is up and running, even if it's behind a firewall, such as using ICMP, UDP, and TCP if necessary. ICMP and UDP tend to be more stealthy, in particular UDP, since UDP is connectionless, meaning it doesn't leave much of a trace when it connects. So we see the status of the host as up and that the host is accessible. This tells us, this is a quick way to determine using our reconnaissance scanning whether or not the system's up. Here are the ports that were found to be up. So out of the 1714, 1,700 were closed. 14 were open. They include anything from SSH through X11. NMap uses its translation file to to resolve the service number to names, or the port numbers to names. That's the NMap services file, which is why in this report, this concise report, we see translations from port number and protocol type to the state of the port to the name of the port. So we now know that 22, if we didn't already, is open and that it is SSH. Scrolling down, we see that data files were read from user share NMap. We told you this is a key directory when using the RPM setup that NMap relies upon to translate items such as ports, protocols, names of services, etc., MAC addresses, and so on. Now notice there's no mention of the type of MAC address associated with the loopback adapter. There certainly is a MAC address, but no definitive network adapter was returned. Before we get into that, which is a different type of scan, notice towards the end, NMap returns that it was done. It scanned one IP address, and of which one was up, and it took in total 409 of 1,000, or 409 thousandths of a second, to scan the system. And the number of raw packets that were sent, 1714, with the transfer or total number of packets transferred, total number of packets received. You'll often find that the ratio between sent and received is usually half, or 1 to 2. Sent to receive, that is. So in this case, we see that about 75,000 bytes were sent and about double that were received, which is a good indication of NMap doing its work as expected, meaning little input, lot of output. We sent 1714 packets, we received 3442 packets. That's a basic scan. Let's move on to a different scan, scanning our routable IP version 4 address. An if config will tell us that address. And since we've SU'd in, it's not in our path, so we'll execute it using /sbin. Here's our routable IP version 4 address, 192.168.75.10. So we'll copy this address, NMap verbose, the IP version 4 routable address. The same scan takes place, but still no indication of the network card type. Same ports are open, although in this case 1701 ports are closed, which means in the previous example one of the ports is bound exclusively to the loopback adapter as opposed to the routable network address. And if we compare and contrast the two lists, we'll see which service it is. We see that in both cases SSH through DNS services are up, but if we netstat NTL grep 127.0.0.1, we may find the culprit or the service, and it could be 2208. When I certainly don't see it in the second list. Let's see if it's in the first list from the earlier scan, and it isn't 2208. So of the two, there is one port, or a one-port differential, but nonetheless the scan comes back similarly. In this case, it took 2.029 seconds to scan, and again, little input, lot of output. Now these are all, of course, basic scans. There are many more options. If you execute NMap with no options, you'll see those many options. We know the basic syntax is that you indicate NMap with a scan type, and if you elect not to or omit the scan type, then NMap defaults to TCP SYN if you're logged in as root, or TCP connect if you're logged in as a non-privileged user. When you execute NMap with no help, the version's returned, the usage is returned. We see how you may indicate targets. So we can indicate host names, IP addresses, networks. Here are some examples of indicating, for example, a specific host, a domain /24 bits, a single internal host, or a range of internal hosts on multiple subnets, 0 and 1, on the 10 network. We also see that we can indicate hosts /networks by indicating IL, or lower IL, followed by the input file name. So we can populate a text file, especially if we execute scans on a frequent basis, in particular via cron tab. We can indicate an input file as our source file and make it much easier to distribute those scans. We have the ability to choose random targets, to exclude specific hosts. So if you have a range of hosts, let's say 10.0.0-255 through 1.254, we can determine between these two subnets, 0 and 1, to exclude a list of hosts by indicating --exclude, or by setting up our exclusion list in a file. So we can have one file with hosts or networks to include, and yet another file which includes hosts and or networks to exclude, so we can narrow that list down. Host discovery. Whether we want a list scan, simply list targets to scan, a ping scan, this is a very good way to tell if ping is permitted in your environment whether or not a host is up. Very few packets are sent. While we look through these options, let's try in a separate window to execute some of the scans that we're discussing. So we'll su in NMap verbose ping scan. Let's go for the default gateway 75.1, and very quickly, as you can see, in half a second roughly, or 4/10 of a second roughly, we were able to scan the remote router without sending too many packets and determine that the host is up and running. This doesn't return, of course, the ports that are open. It simply sends an ARP ping scan at layer 2 of the OSI model, and it performed MAC address resolution to tell us that indeed the device is a Cisco device. And instead of sending thousands of bytes, only 42 bytes were sent. And since it was an ARP ping scan, usually what's sent is also expected on the receive side. So ping scan is a great way to tell whether or not hosts are up on the wire. If you know for certain that the hosts are up in your target list, you can indicate upper PN, which saves you some time on scanning because it treats all of the hosts as online. Sometimes, especially when hosts are behind firewalls, NMap will have difficulty determining whether or not the host is up and take a much longer time to complete the scan than you had anticipated. So if you know the hosts are up, or you suspect they're up, or if you'd like to simply treat them as if they are up, then use upper PN, and you'll save some time in the overall scan process. There's some additional options here for you to peruse. Here are the scan techniques below. SS, ST, SA, these are all different types of scans. TCP SYN is the default. That's the SS option if you're logged in as root. And if you try it as a non-root user, let's drop our privileges here and try to NMap. Let's go with the default gateway once more. You'll see that the type of scan performed above is a ping scan, that is, not a TCP SYN scan. And if we attempt to perform a TCP SYN scan using SS, it tells us it requires root privileges. ST, which is the TCP SYN scan, or TCP connect scan, works as expected because normal users are able to complete TCP three-way handshakes. That is how, indeed, we're able to connect to websites like nmap.org by completing a three-way handshake with the nmap.org web server. So here are the different types of scans. Window, MIMAN, ACK scans, which is even more stealthy. A UDP scan. By default, NMap doesn't scan using UDP. So if you want to search for UDP ports, you'll need to use SU. Additional scans, null, fin, Xmas scans, additional flags, and other options. You can do bounce scans using FTP, bouncing your scans off of remote FTP hosts. Below we see a grouping or an area for port specification and scan order. Using -P in a range of ports, one or more, you can indicate which ports are to be scanned using the syntax you see here, such as a specific port, a range of ports, a list of ports, comma delimited, etc. Here's another way to speed up NMap's scanning by indicating a fast scan. This scans fewer ports than normally than NMap normally would, which is the roughly 1,700 ports, which returns results regarding whether or not the system's up and available much more quickly, at which point you could then determine to or make the perform a more comprehensive scan after you've determined that the host is up and running. There's an ability to scan top ports. Top ports, of course, include ports such as web, FTP, SMTP, the common internet ports. Here's a way to indicate a ratio, the ability to scan ports more common than a given ratio. So you can balance or weight your scans based on a ratio. Service detection. SV attempts to determine the service running behind the port that's detected. So let's try a service detection scan, which will indicate using SV, for example, as root. We'll label this as service detection scan. Using NMap verbose SV followed by a target such as our remote system 192.168.75.199. Now be warned that service detection scans tend to be slower than standard scans because more work is required, more matching, more pattern matching is required to discern whether or not a given service is translatable. But since we're scanning on our local area network, it shouldn't take too long to come back with information, useful information. So here we see the MAC address. We see that the remote system has a MAC address range that's associated with the VMware company. Indeed, 199 or Linux CBT Serv 4 is a VMware instance of the remote system. SSH is the port that's open on that remote system. If you recall, we filtered using IP tables recently, which is why SSH is the only protocol to return. However, NMap went one step farther in returning the version of SSH running on the remote system, which we could always confirm opening a new shell, telnetting over to 192.168.75.199 port 22. Indeed, we see it's OpenSSH 4.3. So NMap's able to determine that for us relatively quickly. It took, from what this tells us, 9.4 seconds, whereas a standard scan would have taken roughly a fraction of a second to maybe a couple of seconds. So service detection scans definitely take a little longer time. Now this is not an OS fingerprint scan. This is simply a way to resolve the name of the service, the name and version of services running behind given ports. Now on that remote system, Linux CBT Serv 4, if we execute an IP tables upper L, we'll see that it's currently accepting the following. So SSH, and it's dropping everything else. So IP tables flush input chain will return the chain to normal. The rules are still saved in etc sysconfig IP tables, so we can always restore the rules by restarting IP tables. But for our intents and purposes, we want to see how NMap is able to determine the services that are bound to the various ports, including version information wherever applicable. And as we can see, it's detected many more ports for the same host. 17 services have been detected. Now NMap needs to perform matches against the banners that are returned and any information returned by the remote target against its database, its services database. So here we see the version of VSFTPD on port 21, SSH, Linux Telnet, Postfix SMTPD. So far these are all correct. Apache in the version 223. This is right on the money. Dovecot, IMAPD, OpenSSL 443, which is really Apache with SSL support. MySQL 3306, and it says unauthorized, but nonetheless it's available on 3306. So this has given us a lot of information in just about 21 seconds, just under 21 seconds. So this is a service detection scan. And well, let's just note that it doesn't always work, it attempts to resolve services to names and versions, such as VSFTPD version 203, or whatever version is running on the remote system, 205 that is. So that's a service detection scan. Now an OS fingerprinting scan is also slow. It attempts to identify the operating system. If you need a way to tally up the OSs that are running in your environment, this is the tool for you. NMap verbose with the O option followed by the target system's IP address will help to determine the OS running on the remote system. It doesn't always work. However, at least you'll get a good idea. For example, if your environment's primarily loaded with Windows systems, use NMap followed by a target of the subnet or subnets that you're interested in scanning, providing your NMap scanning system has access to those subnets or subnet. And shortly enough, you'll have a list of hosts available on your network, and if you use the reporting option, the information will be stored in a file, and you can peruse it offline. So let's try an OS fingerprint scan of 199, which is a Linux box. It tells us in the output that it's running Linux 2.6.x, which is good enough for us. We know it's a VMware MAC address, Linux in a kernel version, and it gives us a range of what version of the kernel it could be running. And of course, on the remote system, uname-a returns that it's running 2618, which is close enough for our intents and purposes. So we know we're between 269 and 2621 based on the way the remote system has returned. OS fingerprinting also tends to be faster than service detection, especially for systems with many services exposed. NMap assigns a difficulty rating with each scan, each OS fingerprinting scan, to give you a sense for how easy or how difficult the system is to crack in terms of TCP hijacking, TCP sequence prediction. Now, insofar as output formatting is concerned, if we just take a look at our documentation for a moment, we'll see that there is a reporting section in addition to OS detection, which we've looked at briefly using the upper O option, and there's some firewall IDS evasion tactics and timing and performance. There's some cool features in here which allow you to throttle the way in which NMap will perform a scan. Let's say you need to scan one or more of your subnets, but because of your intrusion detection software or because of traffic concerns or both, you need to stagger or stall or throttle the scans. You can set up that timing by following the information you see beneath timing and performance, such as how many seconds between each scan, or the interval between each scan that NMap is to perform the next scan, or the next query, or the next probe. As far as formatting is concerned, pay attention to the output section. You'll see the different formats supported. ON, or lower O, upper N, is the normal output that you see on the screen. So when we execute NMap, let's find a window here. Verbose turned on, lower O, upper N, against, let's say, the default gateway 75.1. This will perform a scan and dump it to the screen. But we should specify a file name. We'll call it linuxcbt router1.scan.1. And what you see on the screen will be dumped in normal format into that file. And there you see it. It includes the ports that are open, the MAC address and any translation if available, and the data files that were read. So the ports that were open that were dumped in the earlier section on the screen are dumped to the file when you turn on the normal option. There are many other options, such as XML. If you have an XML parser or would like to look at NMap's output in a web browser, for example, use the XML version or the XML option. So OX, for example, we'll call this scan.2.xml, stores the output in XML form, and once complete will less linuxcbt router scan, and we'll just take a look, see where the file is. It wrote it as X. We wanted it to be upper X, not lower X. Let's try that again. And once complete will less scan to XML. This is now formatted using XML, and there is a document descriptor which is included with NMap, which can be used in your software that you use to parse the information presented by NMap. But you could use a web browser, navigate to the file, and open it within that web browser. Let's open file, and we want to make sure the file is available to the user linuxcbt, so we'll copy it, or we could symlink it, or either or. hard link it since root's home directory differs from Linux CBT's home directory, and it is indeed beneath Linux CBT temp, so we should be able to get it from temp, and there's the file. So this file can be opened and examined, and it is indeed in a result or in a format that's parsable in your web browser. This is nice and neat, pretty format. It can be used in any browser. It tells you it was initiated at a given time on a given date. It tells you the host that was scanned, and if there are many hosts, you'll see entries. And you'll see results. ARP response to ping, IP version 4 address, its MAC address, the ports out of 1711 that were open, etc. So XML is another neat format for you to consider, but there again, other options exist such as greppable format, the G option, which allows you to produce output which is easily parsable or easily greppable. So look through the output section to get a sense for what's possible. In the miscellaneous section we see options pertaining to IPv6, very important, or the ability to turn on OS detection and version detection. So both service version detection as well as operating system detection using the upper A option. Very neat feature. So let's go ahead and just note that. Reporting, NMap, this is normal output. Of course we need a host to scan, such as 192.168.75.1. Option B, upper X, let's label it as filename.xml, and the other one is filename.txt, and this is indeed XML, nicely formatted output. And of course there's a greppable form using the G option. And as mentioned, OS fingerprinting and service detection will be executed using NMap with verbosity turned on. We always turn on verbosity, although not mandatory, with the upper A option followed by the target. Let's say 192.168.75.1 will be our target, the router, and NMap will attempt to ascertain as much information about the target as possible. Now, all along we've been scanning one host. You certainly can scan the entire network. There's nothing to prevent you from doing so. Let's just include an item which shows you how to do that. Scan the entire network using -A and XML output. So NMap, and let's just indent these consistently. Upper A, the output type is XML with the file name of 192.168.70.scan.xml with a target of 192.168.75.0/24 bits. We'll scan all of the hosts on the network. Let's try this from the shell. We'll clear the screen. And this may take a little longer, of course, but NMap will ascertain the hosts that are up and running on the network. It will then scan those hosts. So momentarily we'll have some reports. We see the router was scanned, and we will also see NMap cycle through a number of IP addresses that are not available on the wire. But again, bear in mind, service detection and OS fingerprinting scans always take longer. So be prepared to wait, especially in a busy environment, a busy corporate environment with hundreds or thousands of computers separated by disparate connectivity in terms of speed and distance and so on. So this is still scanning, and it shows 4, 3, 2, 1 host left. The time, GMT, that it was scanned. And momentarily we'll have a report that's viewable in the web browser. Now again, just to recap, while this scan is ongoing, NMap is a reconnaissance penetration testing tool. It's not as deep as a vulnerability scanning tool, such as Nessus, in its ability to determine vulnerabilities on your systems. but it is good enough to run, let's say, on a daily basis to determine if there are changes to your benchmark, such as new ports that you hadn't opened or don't recognize, to help you determine whether or not there's been a change in your system. Additionally, you can get version information, OS fingerprinting, which is very important, so you can quickly ascertain how many Windows systems, how many Linux systems, how many all types of systems are connected to a given subnet, because NMap uses a variety of methods, not only ICMP, but also UDP and TCP. So it'll find out whether or not, even if there's a firewall, whether or not a host is up and running. Unless, of course, your firewall has some sort of built-in mechanism to thwart NMap, it'll be able to scan your local as well as remote subnets very quickly and determine what's running on those systems. So now we're finished. Let's take a brief look at the file. We see that it is 31,497 bytes, and we'll open it from the web browser where you'll see information for each of the items that were scanned. And we'll wait for it to open. So now we see a link for each of the items. We have a scan summary. The scan summary includes the type of scan that was executed, verbatim from the shell, when the scan began, when it ended. So it took roughly 2 minutes to execute, 2 minutes and 7 seconds. Debugging was disabled. The verbosity level, since I used 1V, was set to 1. And if we scroll through, we'll see the results for each of the hosts. Remote operating system guess, Cisco AirNet, it's actually off. It is indeed between 12.3 and 12.4, but it's not AirNet. It's a Cisco router with a built-in switch. But it's close. Here's a fingerprint. If for some reason this doesn't match precisely the device type, then we can submit this fingerprint to insecure.org with the actual device type. And after the first, we see our local system, any open ports, any extra information related to Samba and other items, etc. So this is a report that is similar to what's produced by Nessus. It's a slimmed-down version. It doesn't have the deep database that Nessus ships with for vulnerabilities, but nonetheless, it is good enough for you to be able to use it on a daily basis in reconnaissance mode to ascertain what's happening within your environment and to compare it against your benchmark. I like to run this utility in an automated fashion, just like we ran it from the command line via cron tab as a user root at an early time in the morning, and then examine the results on a daily basis and compare and contrast it to recent scans just to determine if anything's changed. Not only ports, but perhaps versions. Let's say VSFTPD was updated from 2.04 to 2.05 and you didn't do it, or no one you authorized or worked with did it. So that may be cause for concern. So that is just only one of the myriad ways you may use NMap to help you ascertain what's happening on your network. Now next, we'll be looking at Nessus, which performs reconnaissance penetration testing on a much deeper level because it has a database of thousands of vulnerability signatures that it uses to match targets that it's found against to determine whether or not your systems are vulnerable to potential exploits. So next we'll focus on Nessus.